This is an optimization problem on finding the largest possible volume for a box with the constraint of 1200 square centimeters of material. So the box is given, it's an open top rectangular box with a square base, is to be made from 1200 square centimeters of material. So the base is square, which means that two of the side lengths of the edges are x long, and one of the edges is a different length, so I'll give that variable y. It's a good idea to indicate that the top is open, because it's easy to mess that up, so you might want to label that on your document. And then you have that the amount of material is 1200 square centimeters. So then that means that I know that the surface area, I'm going to use S for surface area, is equal to 1200 square centimeters. Then the total surface area of this shape is the total area of all 5 of the faces. Now remember, there's no top, so that means that the surface area of the shape is equal to x squared for the bottom, because it's x by x, and then these side lengths here are x by y, and if you go all the way around the whole shape, there are 4 of them. So our constraint equation is that x squared plus 4xy is equal to 1200, the surface area. And we want to find out what the largest possible volume is when we use this much surface area of 1200 square centimeters of surface area. So we need to make a guess as to what the side lengths might be to get a surface area that's about this much. So we're going to try and figure out a reasonable side length for side x, such that when I square it and multiply 4 times x times y, I get about 1200. So again, just starting with 10, just to kind of see where we are. If x is 10, 10 squared is 100, and then 4 times 10 times some other length that might be somewhere near 10. So 4 times 10 times 10 would be 400 plus 100. That's at least of the right magnitude. And what I mean by that is if you guessed, say, 100 for x, say the side length was 100 units long, well then 100 squared is already way bigger than 1200. So I know that x can't be that big. So I'm going to go ahead and put 10 in here. And then we need to do some work to figure out what y must be. So I'm going to take this equation, 4xy, and subtract x squared from both sides. And so y is equal to 1200 minus x squared divided by 4x. And then let's clean that up a little bit. That would be 1200 over 4x minus x squared over 4x. And so y is equal to 300 over x minus x over 4. So now we want to figure out what y is when x is 10. So we'll do 300 divided by 10 using this function, 300 over x minus 10 divided by 4. So if x is 10, then the y length is 27.5 Okay, so now that we have a reasonable guess for x and y, we are trying to find the largest possible volume. So what I want to put here is volume, and I know that I can get the volume of a shape by multiplying the length times the width times the height. So if it helps, you can start with that formula. Any formula you know to find a volume of the box. But our box is labeled with x times y, and so our volume with these variables is x squared y. And then we can get a reasonable guess for the volume if the sides are 10 and 27.5 by doing 10 squared times 27.5. So then we get 2750 as a reasonable volume value given this initial guess of 10. Now I don't have any idea whether 10 is close to the right answer, but at least gives me some kind of value to start with. So just to make another guess, because I want you to make at least 2 guesses here, I'm going to try 16. And if you then find the y value with 300 divided by 16 minus 16 over 4, that comes out to be 14.75. And this comes out to be 3,776 by doing 16 squared times 14.75, finding that volume. We still need to finish this equation. The volume is equal to x squared y, and we want volume as a function of x. So I'm going to take out the y and put in 300 over x minus x over 4 and clean that equation up. So volume as a function of x is equal to 300x minus x cubed over 4. And we want to find the maximum of that equation, and we've got a couple typical points on that graph. When x is 10, the volume is 2,750, and if x is 16, the volume is 3,776. Now you could get these volume values using x squared y, or you can get the volume values using 300 times 10 minus 10 cubed over 4. That will give you these same numbers over here. So that means that this length x is the side of box in the diagram, this length x, and the y values here are volume. Okay, and we know that some of the volumes are in these thousands, and we're looking for the biggest one. So the one that we're looking for is likely bigger than these, and so I'm going to go ahead and double these here and say, well, okay, well, double 3,000-ish is 7,000. I don't know if that will be a good window for this, but it's a good place to start. And then I'm going to go ahead and double these ones, and so double 16 is about 30, and hope that my graph fits on a window like this. So let's put it in. So we'll go to y equals, and it is 300x minus, no, is that right? 300x minus x to the third divided by 4. And then we need to set the window, and we said to about 30, scaling by 5s is fine, and then up to say, what do we say, 7,000? And we're looking for a maximum. Alright, so that'll work. So second, calculate maximum. And we have to be on the left, which we are. Move to the right. And then go near the guess. And we have a maximum of, when the x value of the box is 20, is it centimeters? When the x is 20 centimeters, the volume of the box is 4,000, and that's the biggest that it can be. So I'm going to draw in this curve. Doesn't look very good. And it's a little high. Let's try that again. So something about like that. And it was 20 for the x's and 4,000 for the volume. That's x comma volume. So then I think we have most of what we need here. So to answer the question, which is what dimensions will result in a box with the largest volume and what is the volume? So if x equals 20, then y equals 300 divided by 20 minus 20 over 4. So $300 divided by 20 minus 20 divided by 4 is 10. So our answer is what dimensions? So the dimensions are 20 by 10 centimeters for a max volume of 4,000 centimeters cubed. So there you go.